Thursday. March 21st. So I've said this before, I'm going to say it again. We are actually looking at literal equations today and how we solve those for various variables. Okay, so what do we do when there's multiple variables in a problem and we want to rearrange them? Typically, my students are terrified of literal equations. They hate it as a topic. But when we break it down and look at it in a more basic form, they're like, oh, that really wasn't that bad. In fact, it was easier than I thought it would be. Okay. But we're not going to focus on a whole lot with different formulas and equations like maybe we've done in past courses of algebra. Because there's one piece that's like the most important. And the most important piece inside of literal equations is being able to solve for y. So while we are going to look at literal equations as a whole, our largest focus today is going to be on solving for y. Alex will sort of supplement with those other literal equations. But if we're prioritizing, the only piece that you absolutely have to be able to do is solve for y. So the most prime example of literal equations being solved is in science class when you're working with the formula distance equals rate times time. Okay, my students will tell me, well, Mrs. Worth gave me 3 different formulas to pick from. Right? And I had to pick between distance equals rate times time, or rate equals distance over time, or whatever. Okay, those aren't actually 3 different formulas. They're one formula that's been rearranged to sort of suit our needs. Because in science class, if you do an experiment and you have a bunch of data, you don't want to have to keep solving an equation over and over and over, right? You just want to be able to plug and chug. Put those numbers in, do the same process, get out an answer. Okay, so maybe we decide we're trying to calculate time. And so we want to solve this for t. So that arrow with the t says rearrange this so this says t equals. Right? My students go, I can't do that. This is all letters. Here's the key. You need to think about variables as numbers. Think about it just like we were in the POD. So what if instead of this saying distance equals rate times time, this said 4 equals 2t. Just pretend those other letters are numbers. What would we do to solve 4 equals 2t for t? What would we do?
Divide by 2.
Divide by 2. So up here we would divide by 2. What's in the position of 2 down here? R. So let's divide by R. Whatever we do to one side, we have to do to the other. And here's where it's great. You don't have to pick up a calculator. You don't have to check your math. You don't have to know what they are divided by each other because we can't do anything with them. We literally just write down what we have left. So we know those R's cancel. And all we're left with is D over R equals T. Is T by itself? Yes, so we solved this for T. T equals D divided by R. That's all there is. I'm just going to start making up ridiculous letters instead of like pulling big fancy complicated formulas. So let's say we have A plus B equals C. And we want to solve this for A. that this was just like the POD, and every other variable other than A is now a number. So now we have A plus 1 equals 2, right? I'm just making up numbers in there. You could make up B to equal 4,756, but that would be kind of silly, right? What would we do if we wanted to solve this top equation for A? Subtract 1. So what's in the 1 position down here? B, so we're going to subtract B. Again, here is the good news. We don't have to do any math. We don't know what C minus B is, so we just write down what we see. A equals C minus B. Are we okay on that? Oh, I should have started with the letter sooner. Let's solve this for X. Okay, so again, let's fill in numbers for those other places. So everything but X is going to get a number. Because we're just pretending. Instead of saying X times 4, we would probably in our brains think of that as 4X, right? What would we move first? Right, we would subtract 3, so what should we do first down here? Subtract Z. So let's subtract a Z. We just write down what we see. We see W minus Z, so I'm going to write down W minus Z. That's it. W minus Z is just W minus Z. Okay, so I'm solving for X. What operation's happening in between X and Y? Multiplication. How do I undo multiplication? Division. So I'm going to divide by Y. I don't know what W minus Z all divided by Y is. So it just stays as that. So my final answer would be X equals W minus Z all divided by Y. Right? I'm moving things from one side to the other. I can't combine anything, so it just stays as one big long piece.